Hey everyone, and welcome back to the Let's Learn channel. Have you ever looked at an LED bulb and wondered how such a small thing can produce so much light? Well, you're in for a treat. In today's video, we're going on an exciting journey to explore the amazing process of how electric LED bulbs are made. We'll go from tiny semiconductor chips to the bright lights that illuminate our homes and workspaces. Trust me, you'll want to stick around till the end to see the entire fascinating manufacturing process unfold. So, first things first, what exactly is an LED bulb? LED stands for light emitting diode. Now, you might remember those old incandescent bulbs with the glowing filament inside. Those wasted a ton of energy as heat. LEDs are completely different. They use special semiconductor materials to convert most of the electricity directly into light. This makes them super energy efficient, incredibly long-lasting, and they come in a huge variety of colors and brightness levels. Ready to see the magic happen? Let's head inside the factory and dive into the manufacturing process. Our journey begins with the absolute heart of the bulb, the LED chip. This is where the light is born. It all starts with highly specialized materials like gallium arsenide or gallium nitride. These materials are used to grow a large, thin disc called a semiconductor wafer. Think of it like a high-tech crystal pizza. This wafer is then precisely cut into thousands of incredibly tiny pieces. Each one of these little squares is an LED die or chip. When an electric current passes through these tiny chips, they light up, emitting that bright, brilliant light we all know. It's a remarkable piece of engineering, packed into a component smaller than a grain of rice. Next up, these tiny but powerful LED chips need a home. That's where the printed circuit board, or PCB, comes in. Using a highly precise machine called a pick-and-place robot, the LED chips are carefully picked up and placed onto the PCB. The PCB is designed with a specific pattern to hold multiple LEDs, which allows the bulb to create a wide, even spread of light. Once all the chips are in position, the board is sent through a special oven for a process called reflow soldering. The heat in the oven melts a pre-applied solder paste, which then cools and solidifies, securely and permanently fixing the LEDs to the board. It's like giving each tiny chip its own perfectly connected spot. But wait, we can't just connect these LEDs directly to the wall socket. That would be a recipe for disaster. Every single LED bulb needs a driver circuit, which acts as its brain and bodyguard. This circuit is crucial because it manages the flow of electricity from your home's power supply. It takes the high voltage from your outlet and converts it into the low, stable current and voltage that the LEDs need to operate safely and efficiently. The driver is assembled with various electronic components like resistors, capacitors, and integrated circuits. Without a well-designed driver, the delicate LED chips would get overwhelmed by the power and burn out almost instantly. So, this little circuit is the unsung hero that ensures your bulb has a long and happy life. Now that we have the light source and the brains, it's time to bring it all together. The next step is applying a thermal paste or adhesive to the back of the PCB. This is super important for heat management. Even though LEDs are efficient, they still produce some heat, and that heat needs to go somewhere. The thermal paste creates a bridge, transferring heat away from the delicate LED chips and onto a metal structure called a heat sink. The heat sink, usually made of aluminum, has fins or a large surface area designed to dissipate that heat into the surrounding air. This cooling process is vital for keeping the LEDs from overheating, which maintains their brightness and extends their lifespan significantly. A cool LED is a happy and long-lasting LED. With the core components ready, it's time for final assembly. The LED board now attached to its heatsink, is placed inside the main body or housing of the bulb. The driver circuit is carefully connected and fitted inside as well. Then, the most recognizable part is added, the diffuser. This is the white dome-shaped plastic cover that you see on the outside. Its job is to scatter the intense, direct light from the individual LED chips, creating a soft, uniform glow that's easy on the eyes. Without it, you'd be looking at a bunch of blindingly bright dots. Finally, the metal base, the part that screws into your lamp socket, is attached and crimped securely into place. And just like that, we have a fully assembled LED bulb. But it's not ready to light up your home just yet. Before any bulb leaves the factory, it must go through rigorous quality control and testing. Each bulb is powered up to check for any defects. Testers measure its brightness, color temperature, and power consumption to ensure it meets the exact specifications. They also perform aging tests, leaving the bulbs on for hours or even days to simulate real-world use and spot any potential long-term issues. Only the bulbs that pass every single one of these tests are packaged and sent out to stores. This strict quality control is why you can trust that the LED bulb you buy will be reliable and perform as promised. And there you have it. From a tiny semiconductor chip to the finished, tested, and packaged product that brightens our world. It's an incredible blend of material science, precision engineering, and electronics. The next time you switch on a light, maybe you'll appreciate the complex journey that little bulb took to get to your home. I hope you found this look inside the factory as interesting as I did. If you enjoyed this video and learned something new, please give it a thumbs up and don't forget to subscribe to Let's Learn for more amazing behind-the-scenes content. Thanks for watching, and we'll see you in the next one.